The idea of creating machines that can think and act like humans is smoothly transforming from fiction to reality. Humanoid robots, digital humans, ChatGPT, and unmanned cars. Today, there are many applications driven by artificial intelligence that surpass humans in speed, accuracy, efficiency, and tirelessness, but only in narrow areas so far. And yet, this gives us hope to see a real miracle in the near future. Artificial intelligence equal or superior to human intelligence in all parameters. Can AI compare with us, surpass us, replace us, deceive us and pursue its own goals? I hope not. Today, we'll tell you how a miracle of nature, such as the human brain, differs from the main technology of the 21st century, artificial intelligence, and what prospects we have with AI in the future. Actually, AI is not a new technology. The term artificial intelligence was first used by John McCarthy at a Dartmouth conference in 1956. Since then, AI has experienced three booms in decades of scientific and technological development. The first came from the 1950s through the 1970s, when humans consistently invented software for neural perception networks and chat rooms. They managed to prove some mathematical theorems and declared, "The era of AI is coming and that robots will surpass humans within 10 years. But it didn't happen. The second boom was in the 1980s to 2000s. The discovery of new machine learning techniques and neural networks led to speech recognition and ideas for applications, making AI popular again. But after most of the ideas failed, the second boom stopped. But in 2006, the idea of deep learning came up, and in 2012, the ImageNet competition made a breakthrough in image recognition. In 2016, AlphaGo beat the world champion, Go, and on it went. A third boom began, which is still going on today and only getting stronger with the proliferation of language models like ChatGPT. With that came the emergence of new breakthrough ideas and approaches to AI development, such as combining neural networks with humanoid robot bodies to evolve AI in the real world. We talked about the latter trend in detail in the issue in the link below. Today, humans have made great strides in various fields such as cognitive psychology, neuroscience, quantum physics, and brain science. And this directly affects the development of artificial intelligence, especially brain research. Every discovery about the inner workings of our black box leads to experiments with neural networks and the implementation and improvements in their operation. And each such successful experiment even hopes that soon an AI will be created that can think, reflect, and evolve like the human brain. But how realistic are these expectations? Let's start with a simple explanation of how conventional neural networks work. A neural network is a computer algorithm that mimics certain functions of the human brain. It contains virtual neurons organized into layers that are connected to each other. The individual neurons transmit information between each other, thus performing calculations similar to a human brain. But unlike the brain, the neurons in a neural network have a specific numerical value, 0 or 1. The layers of neurons are also connected by simple numbers that represent weight, i.e., the importance of each layer to the next. The values of neurons and the weights of the layers are the parameters of the network. When the engineers train a neural network, they look for the value of these parameters to minimize errors in the results. If the algorithm does not perform well, the developers change the weights of neurons and their connections, optimizing it until they get the results they want. Now let's get to specific differences, how the brain is different from AI. Apart from appearance. Previously, a significant difference was considered to be that neural networks are much smaller than our brain, which was about 100 billion neurons. However, this has all changed with the introduction of ChatGPT 4. Although the developers do not disclose how many parameters make up the architecture in their model, many experts estimate the figure to be 300 billion to several trillion. So in terms of size, we're already losing. But our big advantage is that our brains are much less energy intensive. For comparison, last summer, the Frontier supercomputer surpassed the processing power of a single human brain. At the same time, a machine costing $600 million and weighing more than 3.5 tons consumes 1 million times more energy than our brains. In addition, the brain has an amazing ability to store information, estimated around 2,500 terabytes. The next difference is that in neural networks, typically each layer is fully connected to the previous and subsequent layer. They are ordered and activated one after the other. Our brain has no layers, although it is divided into connected areas with specific specialization. At the same time, we're able to process information in parallel in different areas without any particular order. Does this mean AI can't surpass us? Not at all. In one movement test, a simulated robot was programmed to move forward as fast as possible, but instead of building legs and walking, it turned into a tall tower and fell in the desired direction. From the perspective of an engineer trying to build a walking robot, it's a fail. But from the AI's perspective, it traveled a great distance as fast as possible with minimal effort. Furthermore, take wheat. When the seeds ripen, they don't crumble. The stalk falls to spread them over the maximum area. Wheat took millions of years of evolution to invent this mechanism, and AI managed it much faster. It turns out that a neural network can't think like a human, but it can demonstrate an eerie simulation of almost instantaneous evolution. Further down the line, the comparison is not in our favor. Speed is where the brain certainly loses out. We are much, much slower at processing information. Today, AI is able to perform about 10 billion operations per second, while living neurons are stimulated at a rate of no more than 1,000 times over the same period. This speed of processing also means that AI is able to make a much more informed and correct decision that humans can't do. Although not in all areas, but only where the decision strictly depends on the correct processing of specific data. For example, in analyzing CT scans and diagnosing pneumonia. Our advantage is that AI depends on the data given to it, whereas our thinking allows us to draw conclusions that aren't limited to an input set of facts. In addition, we adopt any change much more easily, whereas neural networks have so far struggled to transfer their experience to other situations. Neural networks do not build models of the world. Instead, they learn to categorize patterns. To date, they do not think, but they only try to imitate human logic, just as GPT is not an artificial intelligence, but works only as a super advanced T9. But don't underestimate AI either. We've already shown in the example with the tower and wheat that neural networks are capable of a kind of creativity, finding unusual solutions to problems. And technologies for recognizing and correctly interpreting language and camera images already allow robots to perform tasks without specific instructions. But will all this enable robots to evolve to the level of human intelligence? The answer might disappoint you, but not necessarily. The fraction of human intelligence that can be modeled for neural networks is just the tip of the iceberg, which includes only logical, explicit, and universal consciousness and intelligence. But every iceberg has an underwater part, and in the analogy of our brain, this is the vast amount of unconventional, illogical, and personalized consciousness hidden from outside eyes. The very theory of the iceberg, by the way, was put forward by Sigmund Freud, and according to him, the underwater part is the subconscious, which occupies a large part of our psychological structure, which is impossible to understand or model. But that doesn't mean that AI can't become super intelligent without copying the human brain, but evolving along its own path. Besides, what makes us think we're the crown of creation in terms of intelligence? We compare ourselves only with those who live on our planet, for example, with kittens, and feel on top. But that doesn't mean we're the only possible form of higher intelligence. Artificial intelligence can think differently than we do, and there is great value in that. AI can find new ways to solve our problems, create new structures and substances, and develop itself in ways that human engineers could never think of. For example, neural networks are already able to write code, and recently Chinese scientists proved for the first time that AI is also capable of designing. Thus, the neural network created by them completely, independently, in just 5 hours, their neural network created a completely fully developed working processor. It would have taken 1,000 times longer for humans to do this with the same inputs. Intellectualization is an inexorable trend of the future. As Google CTO and renowned futurologist Ray Kurzweil has said, we can neither prevent the acceleration of change nor prevent AI from surpassing humans in various fields. The most unique feature of AI technology is that it can independently create machines and endow them with intelligence. It was earlier that all technologies were invented by humans. From now on, technology itself can invent machine intelligence. At the same time, the lack of human qualities, such as envy and malevolence, only make AI better. Neural networks can be incredibly valuable assistants to humans without trying to destroy them. Of course, for this to happen, we need to develop certain security standards for systems with artificial intelligence, and also rules for working with it. For example, if we over-rely on AI, it can lead to a loss of critical thinking skills and dependence on algorithms. But AI doesn't always find the best solutions. For example, in one experiment, an AI system driving a car was ordered to reach its maximum speed on a street with pedestrians. The algorithm behind the wheel ordered the car to accelerate in place. The strategy was brilliant because the wheels were spinning and no passerby was in danger. The simulator achieved its goal 100% of the time. That is, the AI found a solution to the problem that fit the task, but not the creator's intent. Or another example, developers created two algorithms and then pitted them against each other in a game of tic-tac-toe. One of the neural networks quickly found a way to win. It requested moves with unfathomably long memory addresses, causing the opponent's computer to crash. Without an opponent, the first algorithm won by default every time. Thus, it's possible that the future will see so-called general artificial intelligence capable of solving a wide range of problems. But it's also possible that it will be a completely different intelligence profile than human intelligence. Rather than trying to replicate humans, such systems could fill large gaps in our intellectual capabilities, filling areas where we're inherently limited. In such a development, control of the future would remain with humans, but it would be intelligent machines that would help build it. What do you think? Subscribe to the channel and like the video, and don't miss new releases from the world of high technology.